Hello, in this session, we'll see Theorem 2 on adjoint of matrix. So, it says if A is a non-singular matrix of order n, let's say, then as we have already seen in the previous theorem that A times of adjoint A or is equal to determinant of A times of the identity matrix of order n and the other one also. So from here what we can do is, what if we multiply A inverse on both the sides, we will get A inverse times of A times of adjoint A equal to A inverse determinant A times of identity matrix. So from here this will become identity matrix and we can directly write it as adjoint A equal to, now as determinant of A is a scalar, we are taking it on the other side of A inverse and writing it as determinant of A times of A inverse times of identity matrix. And we can see that A inverse into identity matrix will give the matrix itself. So this will become determinant of A times of A inverse. So basically a small conclusion here is, which we will be using further to prove the result, is adjoint of A, adjoint A is actually determinant of A times of A inverse. We'll be using this to prove our theorem 2, and this says that if we try to take the inverse on both the sides, we will have adjoint A inverse as inverse of determinant A times of A inverse. And as we know that determinant A is a scalar, the inverse of this will simply be 1 by determinant of A. So this will be 1 by determinant of A times of inverse of the inverse. Inverse of the inverse. And we know that inverse of the inverse matrix will be the matrix itself. So this becomes 1 by determinant of A times of simply A. So this is one of our result, that is adjoint A inverse is simply 1 by determinant of A times of A. And similarly, if we replace A by A inverse in the expression, we have found that is adjoint A is determinant A times of A inverse. Let's say this is 1. So this is adjoint A equal to determinant A times of A inverse, and putting A inverse instead of A, we will have adjoint A inverse equal to determinant of A inverse times of A inverse inverse. And again, as we know that determinant of A inverse will become 1 by determinant of A, and A inverse inverse will become A. So this is determinant of A in the denominator and the matrix A in the numerator. So from here we have got both the results, and it is adjoint A inverse is equal to adjoint of A inverse, and both are equal to 1 by determinant of A times of the matrix A. So this is the result, and this is the theorem 2, which we have already proved here. Thank you.